welcome to my channel. Now let's discuss the another question paper of theory of computation. Introduction. Hello everyone. Here we are discuss the final exam question paper of 8th semester of Master of Computer Application of International Institute of Professional Studies, Davv Indore. Now see the first question. Give notation of representation of following component of formal language of following types. Answer is first one, alphabet. Notation for alphabet is sigma. String. Notation for string is W, S and A plus B का whole clean star. Option C, empty string. Notation for empty string is null or null. Length of the string. Notation for the length of the string is summation of W or summation of X. Prefix and suffix. Notation for prefix in TOC, null, TTO. Notation for suffix, null, TTO, TOC, etc. For language, notation for language is L. Operator on languages, notation for operators on language is intersection, union, concatenation, cleanse star, and complement. Now let's see the second question. Define FA, acceptance of string by FA. Answer is FA stands for finite automation. It is a mathematical model used in computer science and formal language theory to represent a system that processes input according to a set of rules. A finite automation consists of a finite set of states, a set of transition between these states based on input symbols, an initial state and one or more final states. Acceptance of a string by finite automation refers to whether the finite automation, when given an input string, reaches an accepting state or final state. After processing an entire input string, if the finite automation reaches an accepting state, it means that the input string is recognized and accepted by the automation according on its defined rule. Otherwise, if the automation does not reach to accepting state, to the string is rejected. Now see the question number first C. Give four difference between NFA and DFA. First one, transition function. For FA, in a FA, for each state and input symbol there is exactly one transition leading to a next state. For NFA, in NFA, for each state and input symbol, there can be multiple possible transitions leading to one or more next state. This non-determinism allows more flexibility in transition. On the basis of acceptation criteria for DFA, a string is accepted by DFA if the DFA reaches a designated accepting state after processing the entire input string. For NFA, a string is accepted by NFA if there exists at least one path through a state of NFA that leads to an accepting state after processing the entire input string. On the basis of handling and rejecting input. For DFA, in a DFA, if there is no transition defined for a given state and input symbol, the machine gets stuck and rejected the input. For NFA, in NFA, if there is no transition defined for a given state and input symbol, the machine can simply ignore that input symbol and continue processing the input string. It only gets stuck if there are no valid transition at all. On the basis of state space DFA. The state space of a DFA is typically large compared to an NFA or the same language because DFA needs to account for all possible combination of states and input symbol. For NFA, the state space of for NFA can be smaller than a DFA for the same language because NFA states do not need to represent every possible combination of state and input symbol due to determinism designing. Question first D. State true or false. Here are 3 points. Now see the answer. Option A. If L is the language accepted by NFAM, then L also is accepted by DFA. Is true. For every NFA, there exists an equivalent DFA that simulate that behavior of NFA is true. In NFA to DFA conservation conversion for n state NFA there exists for most to n state in DFA is false. Now see the question number second A. Well, what are regular set or regular languages? What are the valid operation used in regular expression? Answer is regular sets are known as regular language are fundamental concept in formal language theory or computer science. A regular language is a set of strings that can be described by a regular expression or recognized by a finite automation. These languages are simplest and most well-defined class of formal language. In simpler terms, regular languages consist of patterns that can be represented using a finite set of rules. These rules typically involve simple operations like concatenation, alternation, means union, cleans star, and cleans plus. Regular languages are widely used in various fields including computer science, linguistics, and theoretical mathematics. Due to their simplicity and each processing, they they form the foundation for the complex language classes and are essential in the areas such as pattern matching, text processing, and compiler designing. The valid operation used in regular expression including first concatenation, combining two regular expressions to match strings formed by concatenation for a string matched by original expression. For example, if R1 equals to text AB and R2 equals to text CD, then the R1 R2 matches ABCD. Operation second union. Combining two regular expressions to matches strings matched by either of the original expression. For instance, if R1 text cat and R2 text dog, then the R1 and R2 matches cat or dog. Third, clean stars. Zero or more repetitions. Matching zero or more occurrence of pattern described by a regular expression. If R text A and the R null clean star matches null A and so on. Cleanse plus. Similar to the cleanse star, but it matches one or more occurrence of the pattern. If R text B, then the R plus matches B, and so on. Grouping using parentheses of group part of regular expression together. This helps specify the order of operation. For example, R text A, text B, text C matches the AB or AC. Now see the question number second B. Complete the table with correct regular expression. Here are the regular languages and fill the regular expression on the basis of their regular languages. Here are the answer for the language L0111 is regular expression is 01 plus 11. For L equals to N0000 and so on. For the regular expression is 0 cleans star. Set of all strings from AB of length 3 or less. Their regular expression is like that. For this language, regular expression is 00 cleans star. For language L 0 and 2 plus n 0 and greater than to 0 is regular expression is 00 cleans star. Even palindrome does not exist. For question number second C, explain Adam's theorem. Answer is Adam's theorem is fundamental result in formal language theory and automata theory. It provides a method for solving system or equation that arise in the context of regular expression and finite automata. Adam's theorem states that given two regular expression and over a finite alphabet, there exists a unique regular expression such that R equals to Q coded R cup P where coded denoted concatenation, denoted union, and the regular expression without a occurrence of the string of that matters by R. In a simpler terms, if we have a regular expression P representing a pattern and another regular expression Q representing a condition or constraint, Adam's theorem allows us to find a regular expression that satisfies the equation R equals to Q coded R cup P. This equation essentially described a recursive relationship between R and Q and Adam's theorem. Provide a cinematic way to find a solution of R. The significance of Adam's theorem lies in the application in solving various problems in automata theory, such as finding a regular expression representing a language accepted by a finite automation or constrained finite automata form a regular expression. It provides a powerful tool for manipulating and understanding a regular language for automata. Now see the question number third. Define the grammar of formal language and complete the following tablet. Sorry, complete the following tables. Here are the table. Here are the four types of languages. Now see the answer. For type 0, popular name of the grammar is unrestricted and phase structured grammar. Condition of format of production rules like that. Name of the language is recursively embedded language. Name of the in automata is turning machine. Popular example is like that. Type 1 is similarly see here, and another for type 2 and type 3 like that. Now see the question number 4. Define context-free language. Complete the table with the appropriate grammar rule. Here are the four languages and fill up the grammar production rule. Here are the answer is for language. First is S is 0 S1 0 1. For language second 0 S1 S1 0 0 1 1. For language 3 0 S 0 1 S1 star. For language 4 0s1 1s0s0110. Now see the question number 5th A. Take a suitable example for demonstrate the following. Leftmost derivation and rightmost derivation and ambiguous grammar. Answer is first leftmost derivation. In leftmost derivation, to each step you replace the leftmost non-terminal symbols in the essential forms. Let's consider simple grammar like SA related to AB, AA, BB. Now let's derive the string AB for the start symbol S. SAB applies rule SAB, AB applies rules AA, AB applies rule BB. Here we always choose the leftmost terminal to expand. Option B, rightmost derivation. In rightmost derivation, at each step you replace the rightmost terminal symbols, the essential form using the same grammar as above. Let's derive the same string AB. SAB applies SAB, AB applies rules BB, AB apply rules AA. Here we always choose the rightmost non-terminal to expand. Option C, ambiguous grammar. An ambiguous grammar is a grammar that can generate more than one phrase tree for same sentence. Let's consider simple ambiguous grammar. SABAC. A equals to AC, BBCB. Now the grammar can generate a string ABB in a two different way. Phrase 1 SAB applies rules SAB, ABB applies rules BBAAB. Phrase 2 SAC applies rules AC and AC applies rules CBA. Both phrases result in the same strings ABB but different structure. This ambiguity makes it challenging to determining the exact structure of the input. String based slowly on the grammar rules. Now see the question number 5th B with reference to turning machine defined with the suitable following for NTM, DTM and LBM. Answer is first NTM non-deterministic turning machine. Non-deterministic turning machine is the abstract computational model that extends the compatibility of the classic deterministic turning machine. Unlike a deterministic turning machine which has a single transition for each input symbol in each state, a non-deterministic turning machine can have multiple possible transitions for a given symbol in a given statement represented with an input. An NTM can explore multiple computation paths simultaneously. It accepts that input if at least one of these paths leads to an accepting state. Option B, DTM, deterministic turning machine. A deterministic turning machine is the classical abstract computational model defined by Allen turning. It consists of a finite set of straight and finite tape divided into a cell. A read write head that can move left or right along the tape, and a set transition rule that dedicate how the machine transitions from one state to another based on the current state, and the symbol reads from the tape in a DTM, and each combination of current state and the tape symbol there is exactly one transitional defined, making its behavior predicate and deterministic. Option C, LBA, linear bounded automation. A linear bounded automation is a restricted version of a turning machine where the input tape server is the only tape available and the read-write head cannot move beyond the boundaries of the input. In other words, the tape is finite and its length is determined by the length of the input string. LBA are particularly useful for studying problems that involve bounded resources such as parsing context-sensitive language, where the limited tape prevented the machine from the unbounded memory. Despite the limitation, LBA have equivalent computational power to turning machine, means they can solve the same class of problem. Question number 6. Give two examples of each of the following. Decision problem, optimization problem, undecidability, PNP, NP and NPC, recursive language. Answer. Option A, decision problem. Halting problem. Given a description of turning machine M and input W, does M halt given input W? Option second, graph connectivity. Given an undirected graph G and two vertices and S and T is a their path from S to T in G. Option B, optimization problem. Traveling salesman problem. Given a list of cities and distance, then what is the shortest possible route that is visit each city exactly once returns to original city? Knapsack problem. Given a set of items, each with a weight, a value, determine the terms to including an knapsack to fix the capacity of maximizing the total value. Undecidability. Halting problem mentioned earlier, the problem of determining whether a turning machine halt on a given input undecisibly. Post correspondent problem. Given a finite set of dominies, each marked with a two string, there is a sequence of dominies that can arrange to match the top string with the top bottom string. P and NP. P for polynomial time problem, like checking if a number is a prime or sorting list of a number can be solved in a polynomial time. Graph coloring. Given an undirected graph G and an integer K, can the vertices of G be colored with at utmost color such that no two adjacent vertices share the same color? This problem is NP but no known as be a P. NP and NPC. Subset sum problem. Given a set of integer and it target sum, if there are subset of integers that added up to a target sum, this problem is NP Boolean satisfiability problem. Given a Boolean formula, is there an assignment of truth value to variable that make it a formal evaluate or to true? This problem is NP complete, meaning it won the hardest problem in NP. Recursive language. Recursive regular language described by regular expressions such as the language of the string containing an even number of zeros. Context free language. Languages generated by context free grammar such as the languages of balanced parentheses. Question number 7. Explain the following. Chomsky hierarchy, PDA, 2PDA, NPDA, recursive embedded language. Answer is option A, Chomsky hierarchy. The Chomsky hierarchy is a classification of formal grammar which is a system for generating a string of symbols according to certain rules. This grammar were proposed of Norman Chomsky, a linguist and cognitive scientist. That hierarchy consists of four levels. Type 1, unrestricted grammar. These are the most powerful grammar where they are no restricted or the production rule. They can generate in a recursive embedded language. Type 1 context sensitive grammar is in this grammar the production rules are such that they are allow for the manipulation of symbols based on the context of the string. The grammar generated the context sensitive language. Type 2 context free grammar. This context free grammar have production rule where the left hand side consists of the single non-terminal symbol and the right hand side can be replaced by a string of symbols regardless of context. CGF generated context-free language. Type 3 grammar, regular grammar. These are the simplest grammar where the production rules are limited to the non-terminal symbol on the left-hand side, the string of the terminal and the non-single terminal. On the right-hand side, the regular generated regular languages. Option B, PDA, 2PDA, and PDA. PDA stands for Push-Run Automata. It is a theoretical computation science concept used in the theory of computation. It is extension of the finite automation with an added stack memory. PDA are defined by a set of state, a finite set of input symbol, a finite set of stack symbol, a transition function, and a start state and set of the accepted state. They are accept language generated by a context-free grammar. 2PDA. 2PDA is a variation of PDA where the stack can be accessed from both ends. This means that stacks can be popped or pushed from either the top or bottom. NPDA and push down automation. And NPDA is generalized of a PDA where there is a stack instead of just once each stack operator independently but can interact with the through the transition function. This allows for even more computational power. Option C, recursive ambient language. Recursive ambient language, also known as a recursive ambient or computably removable language, are set of strings that can be recognized by turning machine. A language L is a recursive ambient if there exists a turning machine that can halt and accept a string belonging to L and there halts and rejects a loop or indefinitely for strings not in L. This meant that all regular context-free, context-sensitive, recursively ambient language are part of the set of recursive ambient language. They are the language recognized by unrestricted grammar in this Smoky hierarchy. Thank you, everyone.